All right, greetings YouTube. This is Beautiful Mind. This question comes in from one of my pre-cal students. So, assistance with graphing. This question says to graph this function by using transformations on the appropriate basic function of this form. State the domain and range of the function and the vertical asymptote of the graph. Okay. Let me introduce this if I can. Can I? Text box. Yes, that's fine. Paper. Let's introduce some graph paper. Okay. So we have graph paper. So then it says, all right, so we want to graph y equals the log base 1/2 of negative x, okay? And we're going to let the parent function, we'll let it be in blue, y equals log, the appropriate, okay. All right, let me kind of do this then. Let me see. Now, in general, the general shape of a log function, I'm just going to do a quick sketch, not anything precise just yet. The general shape of a log function, you have, like a vertical asymptote, and then it typically takes on the form of like this, right? Now so that if that's that. So now if f of x equals log of x, if that's our parent function, and let's just let this be our function, we're just going to call it g of x. So then if I was going to write g of x in terms of f of x, then let's see, g of x will be equal to, okay, actually, yeah, let me change that a bit. Let me get rid of this. So, but that's the basic function. That's the general function of a log. Now, if we multiply the inside of our function by x to get that, negative on the inside, we multiply x by negative on the inside of our function. That's usually a horizontal manipulation, and it's going to flip it over the y-axis. So this should flip, and our g of x should take on a form. It should look like this. Now, just kind of looking ahead with the vertical asymptote here. We didn't move left to right or anything, or up and down. Oh, and that's not a half. That's 1/12. Okay, but still, 1/12. So let's get a little more precise with our drawing. So now if we wanted to graph this log, right, let's write it as an exponential, so the base is going to swing, right? So then we'll get 1/12 to the power of y equals negative x. Then I'm going to move my negative to the other side, so then we'll have a negative 1/12 to the power of y equals x, okay? So then, if we were going to graph this, why are you behaving like this? There we go. All right. So now, if we want to graph this, we can just make a table. Now that it's in exponential form, we have x and y, right? Now, in this form, it's easier to choose values of y. So I'm just going to say, I'm going to go let y be -2, -1, 0, 1, and 2. I just chose my values of y. I'm going to find the corresponding x's. Because if you choose the x's, that's going to be harder to find in this case. But if you choose the exponents, choose integer values of the exponents, then it's easy to kind of create a table. So then if y is -2, that's going to be, it's going to flip. It's going to become 12 squared, which is 144. So this result is going to be -144. When y is -1, it'll flip, and it's going to be 12. Then it's going to become -12. To the 0 is 1, so that's -1. Okay. When y is 1, then we get a -1/12. and then y is 2, it's a negative 1 by 144. Okay, so then let's now put these on a graph. Now my x's go from negative 144. Maybe it might be better to, well, we can do the negative 144. That'll be fine. Okay, that might be an appropriate window, but we can do it. I guess more reasonable would be let x go from negative 1 to like 2 or 3. Sorry, x goes from negative 20 up to the right. So let's actually move this bar a little to the right. Okay. So we need to get to negative 20. We're not going to 200. That's going to be way too much. 10, let me see, 5, 10. So we'll go, let's go 2, 4, 6, 8, 10. So we'll go by 4s. We'll say 4, 8, 12, 16, and that's enough. And then this is 4 here. This is my positive x. So now the x's, we went to negative 20, and this is negative. Okay, this is my origin. Now the y's go from negative 2 to 2. Let's see, 2, 4, 1, 2, 3, 4. We can go to 3. So let me see if that's 1, 2. That's far enough. And then 1, 2. Okay. So now you just kind of have to think about your window. You have to think about what's a good window to capture your x's, what's a good window to capture your y's. Okay, so now we're just going to plot these points. So now the 144 is way off our graph, so I'm going to skip that one. Now when x is negative 12, y is negative 1. Okay, so x is negative 12, y is negative 1, so we're here. When x is negative 1, y is 0. That's not behaving like I was anticipating. Let me think about this for a second. The log usually goes like that. Flips it up and down, but we didn't do the outside by negative. We did the inside, so it should be a horizontal. It should flip like that. 1/12 to the y equals negative x. Negative in front. So now, negative 2, 12 squared, negative 144. So x is negative 12. Why did it flip vertically? It did a double flip. I feel like I'm not graphing something right. Let me kind of finish plotting these and see what happens, and we'll do some exploring. So when x is negative 1, y is 0, so that's here. And then when x is a negative 1/12, we're at 1, so here y is 1, and then it goes like this. Now this is not behaving like how I anticipated. I'm trying to think, why did we flip vertically? Unless I just didn't do something right somewhere. Log of, oh, maybe that fraction. Oh, okay. Yeah, see this, okay. So when I graphed my anticipated result, I only factored in the negative on the inside. I didn't factor that base being between 0 and 1. When the base is between 0 and 1, okay, so for exponentials, when the base is between 0 and 1, you typically have exponential decay. So then if you have decay and you rotate, how does that? Yeah, I think with my original graph, I didn't factor in that base being between 0 and 1, so that's why it's not matching my anticipation. But this one, I think, is okay. I think it's okay. Yeah. So, I'm going to strike through this. I'm going to say that this was off. But, just trying to look ahead.